Tencor Alpha Step 200 Surface Profiler. This system has a manual sample holder stage which can hold up to 5-inch wafers, and also place a 6-inch wafer, but care should be taken to notice it. When we move the stage to the back, it may touch the back wall. So the system also has a nice top plate here. This plate can be removed just in case if the sample is too thick. And the stylus, which is visible from the mirror here, as we place the sample, we have to place the sample such that viewing through the mirror here, the sample is right under the positioning of the stylus at the desired location, just a ballpark, because once we raise the table using the up button here, now we can see the pattern. If the patterns are already known, and that will be easy to move it in such a way. Here is my standard profile sample here with a profile of about 9,500 angstroms. So we have to make sure that the positioning is good. We can profile it from left to right or right to left. It is selectable in the program menu. So when you press the enter button, you can see the menu items here. So we can select the range. By pressing the range button, we can select a 2000 micrometer scan, and then it will also show the speed at which we can change it. So it's quite possible to select the scan length and the scan rate using this selection buttons here. We can also select the mode in which we want to display. You want to display in kilo angstroms or micrometers. If the step height is of the order of few tenths of micrometers or in micrometers, you can select the appropriate range. So by pressing the print button, I'm able to select either only data mode or summary print or screen print. So I'm going to show how the screen print looks like. So there are other menu items here. By pressing the video button icon here, so here the parameters can be selected by pressing the abort key. If we press the abort key, you can select the display, either normal or raw data or normal, so whichever you like. And by pressing the level key, which is this red button here, we can change to display or measure angle or area. And by pressing hash here, we can select either filters on or off. So just like that, we can change the other parameters. That is, change by pressing video again, you can go to the scan parameter changing screen, or by pressing enter key we can exit this test mode, or we can also, by pressing the dash, we can change the time and date. This system has a battery, a 3.9 volts battery installed in it, and what it does is it helps to save the program parameters, and we can restore the parameters in 9 whenever we desire. The programs can be stored in 0 to 9 program numbers, and they can be retrieved and to the desired selected program with the desired parameters. So by table up and down, we can read the stylus force, and there is also a plot. By pressing the plot key, we can change the area either positive or negative. So I'm going to quickly exit the screen and demonstrate a scan. So as soon as the table touches the surface, the stylus is. Now here is the first scan. It is scanning it from left to right. And we can, while scanning, we can also press the video key and actually see the raw data plot. So the advantage of looking at the raw data plot is to see if the stylus tip is profiling either horizontally or in an angle like this. If it is doing this, then there is a knob here, a micrometer, which can be adjusted to level it. Also, when the table is up, we can either zoom into the video. For very fine patterns, we can use the zoom knob to locate a desired pattern location. So the scan can be aborted by using abort key at any point of time and the reset. So I have certain VLSI standards here, and I'm going to show. So I'm pressing the down button to lower the table. It is always important to lower the table whenever we are loading or unloading a sample, so that at any point of time the stylus is not disturbed. So here is a 8 microns sample here. It's a glass etched out. So I'm going to show how this profile looks like. Tencor profilers are very rugged profilers, very old, but they're very easy to operate. A detailed manual is included with this system, and it helps the user at any point of time. Referring the manual is a good idea. All the operation of the system is from this keyboard. And there are output signals such as a video signal and the RS-232 signal available on the back of the system. So here is the 8 micron profiler. I'm going to show something how we can actually measure the profiler's surface. So I have a cursor button here. By pressing it once, I can move one cursor. There is a small icon here that appears showing that particular cursor is selected. There's one more vertical cursor on the left hand side. See, when only that one is selected, we can move only the left hand cursor. By pressing and selecting both of them, we can position it evenly on either side of the profile. Sometimes we can replot it And by replotting, what we did is we zoomed on to the interesting area, the step area, and then we can once again reposition the cursor within 100 microns of the step. So thereby, now the left hand cursor is at the top location and the right hand cursor is at the bottom location, and it's measuring 80.23 kiloamps, which is 80.23 kiloangstroms is equal to 8 microns. So I'm going to print this screen by just pressing the print button. You can see the thermal printer starts to work, and first it prints the summary, and then it goes ahead and prints the actual graphic profile here. That's it. So if a graphic profile is not desired, it is always easy to print only the summary as well. So when we select the data transmit, we should have a properly configured RS-232 signal receiving either computer or a data acquisition system, and we can have a summary printed on that. So the details are explained in the user's manual. So this monitor is a monitor whose brightness or contrast can be adjusted by single knob. So if the monitor screen brightness is to increase, then the top cover has to come out, and the parts are directly on the CRT monitor driving board. But as such, the image looks good. Now I'm going to place a wafer and run a scan just to demonstrate how a pattern wafer can be profiled using this surface profiler. I have a wafer here. I'm going to load it, and so the top circular sample stage plate can be rotated in order to align it for the pattern to be visible vertically on the screen. Now place this in, and I'm going to scan it to see this is just for a demonstration. The sample is pretty old, and we can see various surface profiles here. So when the system is in standby mode, it is always safe to lower the table all the way down and then reduce the brightness of the screen. So there is a Allen key, the smallest one in the Allen key set. You have to place the Allen key through this opening here, and then we can adjust the stylus force while by lifting up the table. It has to be done only if the force is to be adjusted above 15 milligrams. Currently this system is adjusted for 15 milligrams. So the exact location of the screw is shown in the manual. So this profiler is basically to read the surface steps which are in 3D, but by profiling it we are getting a 2D scan of that. So in other words, a step height from here to here is equal to what we see here. So care should be taken to select the scan speed properly, because if the step width is too low and the scan speed is too high, it's possible that the profiling won't be accurate, something like this. So at that point of time, it is important to keep in view what is the radius of curvature of the stylus tip. Even that matters. For very fine patterns, very fine tip should be selected, as explained in the user's manual from the manufacturer. So since this plate is not screwed down, so this system will be shipped with this plate separated from the table. But once the system is in its final installation location, make sure this pin is aligned to the center hole here, and without touching the stylus, locate it and make sure that it is level properly.